afternoon, everyone, and thank you very much for coming to our tech conference today. My name is Yannarak Wannasai. I'm the security engineer at Mercari, and today my talk is about shifting security to the left the right way. So what my talk will cover today is that we will talk about why security is important to your online businesses. And we will introduce a shift-left security approach to improve your software development lifecycle and explain how can you implement shift-left security properly. So before we start up talking about shift-left security, I would like to highlight some information to let you realize why security is important. As you can see in this diagram, which from Verizon 2017 data breach investigation report that collects from the data breach incident all over the world. As you can see, web application attacks still the main attack pattern in last year. However, you may think that Japan is a safe and secure country. Unfortunately, it is untrue when it comes to the internet and cyber attack. For example, last year in December 2017, a security researcher from FireEye discovered that more than 200 million records of Japan's citizens were stolen from more than 50 websites in Japan, and those data were sold in Chinese black market. To make matters worse, this is the data collected by Japan Network Security Association. As you can see, the cost of data breach is extremely high because the average cost is about 548 million yen per incident. This amount of money may lead to bankruptcy for some company. So right now, you may ask to yourself, why developer didn't write secure code at the first place? The answer is application security is very hard. First of all, most university, college, or school, they normally don't teach about application security. So if developers want to learn about security, they have to learn on their own. And not everyone is interested in security. Besides, most security engineers, they have network background or system administration background. So when they want to give recommendation to developers or suggest to developers, they cannot give a proper advice. And the most important thing is that most software development projects, they have strict constraints on budget, time, and resource. For most organizations, they don't even have budget to employ a full-time security engineer so that they can help developers during the design phase, right? And some company doesn't even do the security testing before release at all. So how are we going to improve this situation? How can we fix these situations? The answer is we have to shift security to the left, which means we have to start security at the very beginning and perform security in every single step of software development lifecycle. Probably right now you may have some doubt whether adding security into all of the phases of software development will be effective and efficient and cause my growth. However, I would like to convince you that it's not like that. Here are some reasons why we should shift security to the left. First of all, according to the research from Ponemon Institute research, it showed that the cost of fixing bugs grow significantly as they move along each step of delivery chain. So it means that if we can detect the defect or bug earlier, the cost of fixing bug will be lower. As a result, shifting security to the left significantly saves time money and company resources. Furthermore, security is outnumbered. Probably you have seen this number before, 100 developer to 10 operation engineer to a single security engineer. In the reality, it might become worse because myself have been working in a company that there are 300 engineers and I am the only single security engineer, right? So as a result, security engineer cannot reach their goal by working alone. They have to collaborate with with developers and operation engineer and add security into all of the steps of software development life cycle. And the most important reason is that security should not be a blocker. On the other hand, security should be a business enabler. For example, at Mercari, we want to reduce the time to market of our applications. So we release our application multiple times a day, as you can see here in our release calendar, right? So it's impossible for us to conduct security testing for every single release. As a result, we have to build security into our process, and we have to automate our security task. So now, how are we going to do it? How can we achieve security, shift-left security? So the answer is you have to establish a modern application security program into your organization so that security activity will be embedded into all phases of software development lifecycle, and security will become everyone's responsibility. So, what kind of activities that you should add to your life cycle? First of all, you must have a standard security requirement so that developers, operation engineer knows what kind of security requirements must be implemented for all of the system that you developed. And next, you have to conduct threat modeling by thinking like a hacker to find out what kind of threat that might harm your system and what action that you're gonna put in place to prevent or mitigate the risk from those threats. And to make your test consistent, and you can do the test often as possible, you have to automate the security testing. And you have to implement security as code so that you can embed it into your DevOps process. And finally, the most important thing is that you have to educate everyone who involved in your software development by raise awareness and give education to them. So let's start with defining standard security requirements. Traditionally, requirements are about defining what your software can do or can be. And then developer will use those requirements to implement the features. And the tester will use those requirements to implement the test case. For example, when the developer wants to implement the login function, they have to store the username and the password in the database, right? And make a query to the database to obtain the username and the password. With our security requirements, developer may, decide not to hash the password and use string concatenation to create a dynamic SQL statement rather than using parameterized query, which is secure. As a result, with this approach, it may lead to SQL injection and the data breach incident, right? And in most of the time, I found out that developers choose not to implement such feature. Why? Because security requirements, most of the time, like their manager, their peer, they don't recognize the effort that they put in place when they implement those requirements, right? So why they have to implement it? Because it takes more time too. Unlike developer, hacker has more time, and they want to detect your vulnerabilities and exploit it, right? So if we release such application, it may lead to SQL injection attack. And if the attack succeeds, they can dump all of the username and password. And it can cause some damage to your company as well. So I want to address that we should have a standard security requirements so that developer understand clearly what kind of security requirements that you have to put in place. Probably you might have some doubt that, okay, defining standard security requirements is quite difficult. So how are we supposed to do that? Luckily, Open Web Application Security Project, or OWASP, provide you the open source security requirements called Application Security Verification Standard. And its current version is like 3.0.1. More importantly, there is a Japanese translated version as well. So you can use it as a baseline. ASVS defines 3 levels of security controls, and there are around like 150 controls. ASVS level 1, you should use it because like it's defined the control that you should implement for all types of application. For level 2, it's add up level 1 and add more controls that you may put in place for some application that contain sensitive data that you want to protect. And the third and SVS level 3 is define the requirements for critical applications like the core banking system, the system that controls or manages critical infrastructure like nuclear plant management system, something like that. So if you don't have any security requirements at all, I would suggest that you start with ASVS level 1 because there are only 82 controls, and most of the controls can be testable via automation. So here are some strategies that you can use when you define the standard security requirements. So first of all, I would suggest that to go to the GitHub repository of ASVS, fork it, and then security engineer and developers talk to each other and go through those lists and decide which controls that we're going to be put in place, which controls going to be added into our standard requirements. And you can like continuously add it more and more when like your developer gets more familiar with security. After like we have the standard security requirements, from time to time we need to define a specific security requirement as well. So before we start talking about threat modeling, I would like to suggest how we can let the security engineer engage into the software development process. At Mercari, like other tech company, we use the system called designated hackers. So security engineer will be involved with several software development teams to help defining security requirements and do the review for their software development process. So what security team does during the design phase to help those development team? So they have to understand the priority of the team, understand what they are going to implement, and then support them on conducting threat modeling, help them define what kind of security controls, suggest them what the risks can be, on what the risks can pose if you implement such a way. So I have talking about threat modeling, probably you doesn't get a clear idea what threat modeling is. So actually, threat modeling is just a description of what you worry. So first of all, like you may list the potential threat that may harm your system and decide what kind of action that you're gonna put in place to mitigate the risk associated with those threats. And after that, you keep improving the countermeasure that you implement and see if it's effective or not. So how are you gonna do the threat modeling? First of all, you have to understand how your application works. So to do so, you have to draw the architecture diagram and data flow diagram so that you understand what kind of data that involves, how each component interacts with each other. And then you can brainstorm with the developers and use several techniques to identify the threat. For example, you might use the technique called stride. So first of all, you can do you can think about, okay, what kind of data that can be spoofed or tampered? What kind of action that malicious user can repudiate? What kind of sensitive data can be disclosed? How attacker can perform denial of service attack on your system? And how malicious user can escalate their privileges. And after that, you have to revise the countermeasure and think about the countermeasure. So I want to give you some example. Let's see on this diagram is a simple threat model for login feature. As you can see is that, okay, for login feature, it involves username and password, right? So what we have to do next is that we have to define what kind of threat that we care about most. In this case, we care about account takeover attack, which normally can be performed by conducting brute force attack or credential stuffing. And after that, we decide what kind of countermeasure that we're going to put in place. In this case, as you can see, we're going to implement the account logout feature to mitigate the risks of brute force attack. And we're going to implement the black IP address blacklisting to protect against credential stuffing attack. After we conducting the threat modeling, we have to turn the threat modeling into the misuse case. As you can see here, we can turn the misuse case from the previous example to this misuse story, and then we add this misuse story into the development backlog so that developer can implement the feature out of it. And after we put this misuse story into the backlog, we will use this misuse story to drive a non-functional requirements or functional requirements. But as you can see here, if we just use non-functional requirements, it's unclear, right, how you're going to implement, because it just say that, oh, okay, you just need to implement the control to protect against account takeover attack. With this non-functional requirement, probably it can be neglected, or it can be, sometimes they don't even implement properly. So when it comes to security requirements, if possible, please define it as functional requirement because it's clear and it's more testable. After we have defined the requirements, we have to ensure that our application is implemented as we design. So how are we going to do it? We have to test it, right? To make our test repeatable and consistent, we need to automate this kind of test. So what kind of technique we can use for automating the security testing? First of all, developer has to write the unit test, because writing unit test can be do it repeatedly, and it helps penetration testers like me to focus on other type of attacks, other type of vulnerabilities like business logic and access control flaw, something like that. Next, you have to create a automate integration test. I would suggest that you use the same tools as your QA people use, such as Postman, Selenium, Cucumber, something like that. In this screenshot, it shows how to implement the integration test, it shows you how to detect the SQL injection attack and test whether the security header is implemented properly by using Postman. Apart from those kind of the tools that QA use, I would recommend you to use a tool testing framework like Gauntlet, Mitten, and BDD Security to drive or simulate the real attack during the integration testing as well. Next type that you can do during for security automation is to use static application testing tool. This type of tool will scan to your source code, bytecode or binary, and find the security flaw. However, this type of tool is infamous for producing a lot of false positive. So what I would suggest is that you have to start from the small set of vulnerabilities first, and then reduce the false positive. After that, you send the the report that doesn't have any false positive report to the developer so that developer can use it right away. And we improve this process by adding one or two more vulnerability class over the time once the, the, the system is stable. So what type of vulnerabilities that you can start? I would recommend command execution because it's quite easy. You just like detect for the function that can call the OS command like system, pass through, exec, whatever. The next one is that if you use dependency management tool like npm, composer, maven, you can also detect the use of vulnerable version of software component. And besides, hard coding token is quite easy to implement as well because most of the time token have a specific pattern. You can use regular expressions to detect the hard-coded token as well. Apart from static analysis tool, you can use dynamic testing tool, which is run against your running applications. Most of the DAS tool will act as an intercepting proxy server that record the HTTP requests that go through the proxy, and then they try to tamper the parameter in the request. However, the limitation of this type of tool is that it can detect only several types of vulnerabilities that have a standard signature, like SQL injection, cross-site scripting, cross-site request forgery, and misconfiguration. There are several tools that in the market that you can use, both free and open source tools and also paid tools. My favorite tool is Burp, and probably if you want to use the free tool, you can use OWASP Zap. The tips for you to run DashScan is that first of all, you must ensure that you have a permission from the owner, like your boss, and also inform the stakeholder because from time to time, running the Dash tool against the server can be destructive. It can bring your server down, and it can affect to the performance of the server. As a result, I would recommend to run the Dash tool against the staging environment that match the production as much as possible, and don't just run the test. You have to configure the testing tool so that it can detect that the session is still valid or not, whether like the CSRF token is updated for the sequential requested or not, something like that. And after we automated the test, we have to embed it into our DevOps process by using the security as code. So actually, security as code is is an approach to embed security into your DevOps workflows by using CI/CD tool as a core automation engine for enforcing security and compliance. So how are you going to do it? First of all, you have to understand the current workflow. What kind of tools are you using? What happened when you like check in the code until it's deployed to the production environment? How the test is conducted along the way, and where the test results are recorded, something like that. Once you understand the entire flow, you can decide what kind of security testing or like what kind of security check that you can put into your pipeline. For example, like this is a common like pipeline. First of all, developer commit the change into your source code repository, right? And it will trigger your continuous integration tools to build the application and run the test, like unit testing or like some simple integration testing. And if the application built successfully and it passed the test, it's gonna go to continuous deployment tool and conduct deploy into the staging environment, and then running the deeper test called acceptance test. And if they still pass this acceptance test, it will be deployed to the production environment. So in each state, I would recommend like these kind of tests that you can put in place. For example, during the commit state, I would recommend you to run the unit testing and also checking for like third-party component that is vulnerable. And also you can check the static, or you can run the static analysis tool to check for the code part that were changed as well. For acceptance stage, I would recommend that you use configuration management system and container technology in order to ensure that the staging environment match the production as much as possible. You may use the tools like Ansible, Puppet, Chef, and Docker. And after that, for the operation that takes long time, like DAST or like deep static analysis tool and manual testing, you can run it out of band because it takes much time. And if like it didn't pass the test, you just like roll back to the previous version. Apart from shifting left, we have to shift right as well. So when you deploy the application to the production environment, I would recommend that you have to do the post-deployment smoke test to ensure that the application runs properly, and keep monitoring for anomalous activity and cyber attacks. And when the security event occurs, you may implement event-driven security, which we will like discuss later. And if the incident happens, you have to learn from it by doing post-mortem. So what does event-driven security mean? This is a simple flow that you may implement. For example, you may send the log of your application into Stackdriver logging. And like you can, after that, you may send some log into the cloud pops up topic. And so you may write a cloud function that subscribe to such topic and react based on the message that we receive. For example, you may send the alert to the administrator via Slack or dynamically update the Cloud Armor configuration to block some IP addresses, something like that. After that, we have to implement the security awareness program. So I would like to introduce you this OWASP project called Proactive Controls. It will teach you how to write the code properly. If you want to know deeper for a particular security topic like input validation, authorization, session management, authentication, and etc., I would like to introduce you to OWASP cheat sheet series. You can learn from it. There are more than 50 topics that you can learn. Apart from the training course from OWASP, SafeCode is another resource that you can take a look as well. There are a lot of free courses that you can take from SafeCode. And last thing that you have to do is that to implement the security champion program, because with this program, you can scale security into other teams across your organization as well. And it's also help establishing security culture into your organization. So who should be the champion? It can be anyone who want to upgrade the security in their product or their team, who wants to be a bridge between security team and their development team, who want to help triage security bug for their team. So how are we going to do it? First of all, we have to identify which team that we should have a champion. And then we define what kind of role the champion is, for example, or the champion will educate everyone in their team about security and also like act as the first line for security consulting. And then we nominate that guy to be the champion. And after that, we create like a communication channel for security champion from several teams so that they can share their ideas, share their information. And after that, we should like create some kind of like knowledge-based system so that all of the knowledge are shared and recorded. To maintain the interest of the security champion, I would recommend to establish some events like playing CTF together, try to do the workshop on security, like, okay, learn how to write secure code, something like that. And the key takeaway for today is that we have to do security early and do it often. To do so, we have to automate security tasks as much as possible. And finally, please bear in mind that security is everyone's job. Thank you very much, and that's it for today.